So let's talk about the IPv6 very quickly. And, we are going to go a lot in detail in the CCNA. We will perform these all labs like routing, RAPE IPv6, OSPF, and EIGRP. We will be just configuring using IPv6. So what is IPv6? Basically, why we can't use IPv4 anymore? IPv4 has some limitation because now it is running out of the IP addresses. We need more IP addresses. So that is the reason IPv6 came into the scene to help us. And then we can have, tons and tons. As you can see, IPv4 pool is 32 bit addresses, which is 2 power of 32, which becomes this. These are the total IP addresses we can use in a IPv4. Opposed to IPv6, which is 128 bit long, and this is the number. And really, I have no idea what is it. If you will do the calculation in the calculator, I think your calculator will not proceed.
So never ending.
Yes, it's like never ending. So that is the first thing. That's why we use IPv6. But now we have the solution for IPv4. We are using, as you know, subnetting. Then we have the NAT. If you're not familiar with the NAT, we will talk about the NAT a lot in detail in the CCNA. Basically, it is helping us to convert this IP into the some range public IPs, so we can communicate as well. But this is how it is helping IPv4 for being, running out. So, but still we need IPv6 because, these days, if you go to the Google and search out the IPv6, you will see all the big names in the market like Amazon, Google, Apple, and these all are migrating to IPv6. So we should have a very good understanding about the IPv6. Then this is how it looks like. At opposed to IPv6, we have IPv4, which is using what dotted decimal, and is used decimal. But in IPv6, we are using hexadecimal. This is how it will look like. Okay, so in IPv4, we are using like 4 octets, but in this we are using 16. This is 16 bit. This is 16 bit. This is 16 bit. This is 16 bit, and all the way to the end. So this is a full representation of your IPv6. How on earth you're gonna remember this one? So they have some workaround like this one. You can just squeeze this down by omitting these zeros. As it is mentioned, the zeros can be omitted. With what? This thing. Double colon 2 times, which represent these all zeros as this notation. Then further you can, if you have a leading zero like this one, then further you can type it like DB8 and then AC10 and then FE8001 with all zeros. So we had 1 0 which is omitted from here as well.
As long as it's at the start.
Yes. Okay, and then if you convert this into the binary, this is how it will look like. Sorry. This is just a one-to-one comparison between IPv4 and IPv6, just for your question and answer and interview questions as well. This is a very important slide. So let's go one by one. It is a numeric address, we already know. This is alphanumeric address. It used kind of concept of subnet mask, but it used the CIDR notation. And now you are intelligent enough that what is CIDR? It will use something like /64. It is also known as the notation, bit notation. Then IPv4 has address resolution protocol R, which is nothing but R. If you're not familiar, we will talk about this R in switching section. It uses the MAC address. But in IPv6, it used the thing called ND, which is Neighbor Discovery Protocol. IPsec is optional, that you are talking about, Hefa, the VPN. VPN use a protocol that is IPsec. This is optional in IPv4. But when it comes to the IPv6, it is mandatory. We must have security enabled in IPv6. Then it used concept of broadcasting ARP, but we do not have broadcasting. If somebody asks, does IPv6 do broadcast? No, never. It used called multicast neighbor solicitation. In short, it's also known as NS, to find the host on its same subnet. Then we have IP assignment done manually or via DHCP. But on IPv6, we can use this concept. This is known as stateless address auto configuration. Automatically, if there is even no DHCP server running, you will get the IP. And not to confuse with the APIPA. No, it is not APIPA. You can have the full communication with the help of this stateless address, even if there is no DHCP. Then it uses records are addressed in like a record, and this is quad A record. Then it used the concept of multicast, broadcast, and unicast, but here we have anycast, unicast, and multicast. And anycast is nothing but a new concept in IPv6. If we have, let's say, one Google server, this is host machine in, let's say, in Pakistan. And then we have the Google DNS server. It is located in, let's say, New York. Then one it is located in China. And these both servers have the same information that I'm looking for from my host machine. So why do I need to go all the way New York to receive the information when I can hit the China, which is very near to my country? So this is the concept. Anycast, it will not go to the New York, but it will hit the nearest server, which is anycast. Then we have classes in IPv4 like A to D class support VLSM, and there is no any kind of VLSM, and there is no any class. And we do not need these classes because IPv6 itself is long enough. They have so many addresses, it can accommodate. Okay. And then I just mentioned a more advanced lab in the CCNA module. When you will hit CCNA, you will see this is the complete module for the IPv6. So let's talk about the IPv4 subnetting, VLSM reverse engineering. But unfortunately, in your network pro section, you're not gonna have reverse engineering or the VLSM labs. Actually, I did that lab, but later on with the concern with Danish, he said that if these things are not available, we can do it later on in a CCNA. So that's why we are just hitting IPv4 subnetting, and this is going to be our last slide. Okay, so you are already familiar with this thing. This is IPv4 address, and if you convert into the binary, it is how it will be look like. And this is 8-bit, and the total in length is 32-bit, which is 4 bytes. we have some portion which is known as network ID. This is your network ID portion, and this is going to be your broadcast ID portion, which you can, if you this is how it will look like. So if there is 0.0, it is showing your network ID, and if it is like 255.255, it is representing your broadcast ID. Okay, and whatever in between from 0.0 all the way to 255.255 will be allocated to your host machines. Okay, so let's perform this lab, which is demo time subnetting. Find a number of networks from the given IP addresses, and this is going to be your last slide because I have further more to, and I will just explain about these things. But I'm going to perform this subnetting in this section. So basically, this is the scenario. You are an IT administrator for the organization. Your boss had over to you to give you a simple task. He wants you to take a responsibility to squeeze down the network from the perspective of IP. Currently, you are running Class C network, but you need only 5 networks in Class C. As you wise enough, we know what is the subnet mask for the Class C. Can anyone tell me?
225.225.225.0.
Yeah, in short, you can say 24. Okay. So if we take a look, it has how many network portions? This we talked about the host portion. If I talked about, let's say 192 IP.1.0, this is representing host portion and this is representing your network portion. If you do 8 plus 8 plus 8, which represent each octet, which becomes what? 24. If you do the multiplication this on a calculator like this, it will come up with some value. This is how you are going to have number of networks in your local area environment, which is a lot. But what basically your boss is telling you, I just need 5 networks. How? If I can show you, this is the topology. You need 1 network just for this portion. You need 1 network to connect these 2 devices. You need 1 network for this, 1 for this, and 1 for this, which becomes total 5. So the reason, number 1 reason of using subnetting is just we do not want to waste this whole Class C. We do not want to waste the whole Class C range. So we are just taking out only 5 networks out of this whole Class C, which will be assigned to these different networks. I'm sure if you are hitting this concept first time, you will be confused. But let me tell you, this comes with the practice. We all gone through these practice a lot, and then now we are at this stage that we are now understanding these things.